Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we call Space Nuts. My name's Andrew Dunkley, your host, and joining me from the Australian Astronomical Observatory is Dr. Fred Watson. Hello, Fred.
Hi, Andrew. How are you doing?
I am very well. That's probably the straightest start to a segment we've ever done. I think we should start again.
Yeah, there's something gone wrong. Where's all the patter?
Oh, dear. Maybe next time. But today we've got some really fascinating stuff to get through, so we better get started. But Trappist-1, which has been looking at exoplanets, has found some interesting ones. Perhaps rocky, perhaps wet. We don't know yet, but that's something to talk about. And speaking of wet, the moon Titan, which is wet in a very different way and probably not the place you want to go for a swim, but we're going to look at some of the seas of Titan. And then we'll catch a question from Jordan in Alabama. I've got a bit of a story about Jordan, but I'll tell you that when we get to it, and we might follow up on the launch of Falcon Heavy. But Trappist-1, Fred, what have they been looking at with Trappist-1?
So, really interesting stuff. This is a planetary system discovered by a project called Trappist. And Trappist is an acronym, and I've just been looking in vain to find out what it stands for. I do remember reading it out to you once before. It's a venture of if I remember rightly, the University of Liège in Belgium. Got a very strong Belgian beer overtone to it because the Trappist monasteries, where a lot of very good beer used to be brewed and probably still is. But the point about the Trappist-1 solar system is that it is a dwarf star, actually an ultra-cool dwarf star, which has 7 planets in orbit around it. And they were discovered, and this is how the Trappist project works, they were discovered by the dips in brightness of the star itself as each of these planets passed in front of it, because we are kind of directly in line with the plane of the planet's orbits. So that's how we know there are 7 planets going around them. What that tells you, Andrew, is the size of the planets in terms of their diameter, because the amount of dimming as a planet passes in front of a star is directly proportional to the ratio of the diameters of the star and the planet. So if you know the diameter of the star, and we do pretty well know what these stars are, then you know the diameter of the planet. What is missing, though, from that information is the mass of the planet, but there are subtle ways of discovering that too, because if you think about it, you've got these planets which are in relatively close orbits to their parent star. They are gravitationally interacting with one another, exactly as the planets of the solar system do, but because they're so widely separated, the gravitational interactions are quite small. But it's true that Venus pulls on the Earth, Mars pulls on the Earth pulls on Jupiter. All these things have got, well understood gravitational nudges, if you like, of these planets in their orbit. So we understand that for the solar system. We now think we understand it too for the Trappist-1 system, because by looking at the way the orbits of these planets behave, and you can tell that by the timing when they transit or pass in front of their parent star, you can calculate what their gravitational interactions are, and that leads you to understand what their mass is, each of these planets, what its mass is. And of course, knowing the diameter and knowing the mass means you can work out the density. And the density is what gives you a clue as to what these planets are made of.
So whether or not they're a gas giant or a small rocky planet or something in between.
Exactly so, that's right. So these planets are all roughly Earth-sized. The biggest one's, I think, about 1.3 times the diameter of the Earth. The smallest one is a little bit smaller than the Earth. They're all roughly Earth-sized, and they have masses that tell you that they are almost certainly rocky planets. And that possibly also, because you can tweak this technique to give you more information, it looks as though some of them may have water as well in their composition. So one in particular, I think it is. They've all got, these planets are called Trappist 1, B, C, D, E, F, G, and H.
Makes sense.
Yeah, that's right. You don't include A because A is the star itself. So B is the first planet out. C is the next one, etc. And one of them, and I think it is. I think it's Trappist G. I can't remember. One of them looks as though it might have up to 5% of its mass being water. Now that is compared with the amount of the Earth's mass, which is water. Can you guess what that is?
I thought it was somewhere around 75%, but it might be more.
75% of the surface is covered with water, that's right. But in terms of you're quite correct, but in terms of the mass, and remember you're talking about, an entire planet there, the Earth's oceans contribute about 0.02%. And this...
I see where you're going.
Yeah, so it's much, much more water, 250 times more water than there is in all of the Earth's oceans. So it might be a very wet world indeed.
Sounds like it.
Or, it could be, depending on the temperature, and you can get an idea of the temperature knowing what we know about the star itself and its distance. It might be a very steamy world indeed. It's a very, very interesting world. I suspect that the observations that have been made with basically various telescopes, including NASA's Spitzer Space Telescope, I think they are the discoveries that we've made are probably as far as we can go at the moment. Although there is the thought that the outermost ones, Trappist 1, F, G, and H, are probably outside the Goldilocks zone. That means to say their water will be frozen, so they might have completely icy surfaces, which actually is what we see in our solar system with some of the satellites of Jupiter, Saturn, Uranus and Neptune. They've got surfaces made of ice. So really kind of interesting stuff. But the point I was going to make was that I think our knowledge of the TRAPPIST-1 system will take its next big leap forward when we get new instrumentation. The new generation of telescopes, the ELTs, the extremely large telescopes, which are kind of 5 to 10 years away, but perhaps more especially the James Webb Space Telescope, which is the next big thing in space. It's the replacement for the Hubble telescope. That's got a 6.5 meter diameter mirror, the biggest mirror ever flown in space, at least ever flown for astronomical purposes. We don't know what else has gone on in space, but for astronomy, it's the biggest mirror ever flown. And that, we hope, will tell us much more about systems like the TRAPPIST-1 system. I think it's a very exciting time ahead. That's scheduled to launch next year, and I hope Space Nuts will be discussing it.
Yes, I hope so too, and let's hope that the TRAPPIST system is at the top of their to-do list, because if there is a planet there in the Goldilocks zone with that much water, we probably would be a priority to confirm how much water there is, what the temperature is, and what the potential is for other things to exist in that little solar system.
Exactly, that's right. Who knows what might be there? And that's the great challenge of astronomy, finding out these things.
Indeed. All right, we watch with interest. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor. ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new, new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're going to look at Saturn's moon Titan. Speaking of wet places, this is wet for a different reason, and I don't even know if wet would be the way to describe it. But there are seas on Titan, and they're very, very unusual. Not the place to go for a bit of a dip in summer.
Indeed, that's right. Unless you're an alien species that likes temperatures in the region of minus 180 degrees Celsius, because that's the temperature at the surface of Titan. Remember, Titan, the biggest moon of Saturn, got a very thick and fairly opaque atmosphere of mostly nitrogen, but laced with hydrocarbons, which is why it's got this smoggy, brownish amber look to it that can't be penetrated by visible light, but can be penetrated by radar. And that is why we know so much about the surface of Titan, because of the radar imagery carried out by the Cassini space mission when it spent its 13 years in orbit around Saturn, and many, many flyovers of the surface of Titan. So what we found out, of course, was that Titan, particularly in its northern hemisphere, is rich in lakes and seas. Not lakes and seas of water, but of basically liquid natural gas. It's seas of liquid methane, ethane, and nitrogen. They're the constituents of this stuff. It's rather, basically it's a kind of hydrocarbon sea. Very difficult to imagine what its constituency is like, but we know that it sits on a rocky bed, which is not made of rock. The rocky bed is made of solid ice, water ice. So the water is frozen solid. It becomes what we think of as rock here on Earth. And the natural gases that are gaseous here on Earth, methane, ethane, and nitrogen, at our temperatures are all gas. But at the temperature of Titan, they're not. They're liquid, and they sit in these depressions in the icy surface of Titan. Okay.
So what? Yeah, we've been over this ground before, but what you're saying is because of the temperature on the surface of the planet, water becomes rock and gases become liquid.
That's exactly right. Yeah, there are still gases in the atmosphere, but the ones that we think of as highly gaseous here on Earth, they are liquefied. It's actually a little bit more interesting than that, though, Andrew, just to pursue this a bit further, because at that temperature of minus 180, it's kind of interesting temperature, excuse me, particularly for these hydrocarbons, because methane and ethane evaporate when it gets a little bit warmer, and then they condense in the clouds in the atmosphere of Titan and produce clouds there, which we've seen by imagery from Cassini, and they produce rain, and it's the rain that makes rivers flow on Titan. We've seen evidence of that with the topography beneath the spacecraft, and those rivers flow into the lakes and seas. So there's a whole, what we on Earth would call a water cycle, the evaporation and condensation. But on Titan,
it's a petrochemical cycle.
That's right, absolutely. So that's the story so far. The new bit of this comes from some research carried out at Cornell University in the USA, which is that some of the scientists there have done something pretty clever. What they've done is they've taken all the individual flyovers of the surface of Titan by Cassini, which resulted in these strips of radar measurements. So we've got lots of strips of where we've got information about the topography of Titan, including where the seas are and where the hills are and things like that. But they're all at different angles. These strips are they crisscross the surface of Titan. They actually cover it pretty well, particularly in the northern hemisphere, because that's where all the interest is with these seas being there. But they're individual radar strips. What's happened now is that scientists at Cornell have kind of stitched all these together in terms of the height above, not above sea level, but above a datum, a standard datum. Mm-hmm. So they've essentially fixed the height of all the topography on Titan. They stitched them together because they all overlap, so you can kind of build up a map where the elevations are all referred to the same scale, if I can put it that way. The elevations being the height of the features. It turns out that Titan has, at least the parts that have been mapped, have the same kind of height range as we see in Australia, around about 2,300 meters. But the surprising thing, and the thing that I think is really very intriguing in terms of the makeup of Titan, is that the seas and lakes are all at the same level.
Oh, wow.
Yeah, they're all at the same elevation. And that, because they're so smooth, the surfaces get brilliant radar data from them. They're very smooth. In fact, you don't see the radar reflection. It bounces off in a different direction, which is how we know that they are smooth surfaces. It gives them a resolution in terms of the height of somewhere in the region of 30 to 50 centimeters. So like a bit more than a foot. That's how accurately we know the height of these seas. And that's why this amazing result has come out, that the seas are all at the same level. And what that suggests, well, when you look at these seas from above, you can see that some of them are interconnected. There are channels linking these seas, but not all of them. Some of them appear to be quite independent, but they're still at the same level, which suggests that there might be underground or under ice tunnels connecting them, that they are somehow interconnected, maybe by regions of the so-called rock, the ice bed, which are porous, or maybe there are channels within them that we can't see from above. But a very, very intriguing result indeed.
Yeah, is the reason that they're all on the same level known? I mean, is it a temperature thing, or is it just the way the land lies? Any theories?
Don't know. The implication seems to be, that maybe there's something equivalent to what we call groundwater here on Earth, which is sort of what fills the Artesian basin and things of that sort. If you've got a groundwater system, then there might well be flows in that, which could give you this situation where the exposed liquid, I mean, it's not groundwater, it's ground petrochemicals.
Yes.
But the exposed liquid all falls at the same height because they're interconnected below the surface, and that seems to be the best thinking on that. That there's actually, another little quirky bit is that, and we don't really understand this either, but the smaller lakes seem to be always surrounded by pretty steep terrain, high hills around them with quite steep drop-off. The scientists who's done this work is Dr. Alex Hayes, who's a planetary scientist at Cornell. He's got this lovely quote. He says, they look like you took a cookie cutter to the surface and made little cutouts. And that the lakes are in there. And he suggests that it's because these lakes are formed in what used to be pits or maybe even caves, where something in the underlying material has been dissolved out and it's caved in. I mean, that's the sort of scenery you see in limestone in certain parts of the world. It's called karst scenery, where you've got the rock dissolves away, it forms a cave, and the roof collapses. Yeah. So you've got a pit with very steep sides, and that's the sort of interpretation of what we're seeing on Titan. It's great stuff. Sometimes these pits have got rims up to 100 meters high. Which is really, quite remarkable. It seems to me like the best explanation. I think it's once again, like all these things, Andrew, we need to go back again and see what's happening to get better maps and get better understanding of what's happening on Titan. But Titan's fascination never ceases to amaze me. There's still much to be learned from the Cassini data. I'm sure you and I will be talking about Titan for many years to come.
Yeah, it's an incredible world, and this is quite a revelation. And with the addition of knowledge about the fact that it rains there. Rain must fall on these things and they don't get deeper, so it must be going somewhere. It's very maybe it's spreading out beneath the surface. It stands to reason. It's very interesting. All right, we'll look more at Titan down the track. This is Space Nuts with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Last but by no means least, Fred, we have an audience question. And this comes from Jordan Holt in Alabama. Now, Jordan and I actually started a little conversation last week after he sent his question because I asked him who was going to win the Super Bowl, and we had a bit of a chat about that. And I told him that I was actually on air at the time on my radio station. And he said, how can I listen? So he found us on our stream, dcfm889.com.au, just in case you're wondering. And he listened to us on his way home from work. He works between Alabama and I think he said Mississippi, and put in a song request that somebody brought into the studio, which he didn't tell me he'd done. And so I ended up playing him a song. I bet you can't guess what it was. Sweet Home Alabama. So I've sort of gotten to know Jordan pretty well. So thanks for the question, Jordan. He says, I've been listening to your podcast over here in the States, travelling from Alabama to Mississippi, there it is, for work. Just wanted to say great job. Love information pods about our universe and space-related things. I haven't listened to them all, but I'd love to hear about the human civilization being able to travel to other planets, or at least the potential for future travel. And I love the next line. Y'all doing a great job, mate. Accent's pretty cool as well. Jordan Holt. Thanks, Jordan. Your accent, I'm sure, is brilliant too, even when you write it down. So this is something you and I have discussed in the past, the potential for long-distance human travel. We're nowhere near that. It's certainly portrayed in science fiction films, I think most recently with Passengers, where they were doing a 90-year trip in space in cryogenic pods or something like that. So where are we at, and where does the future lie in terms of being able to travel to other worlds?
Yeah, what a great question. And hi, Jordan, from me too. My upbringing was a bit like yours in that regard. I was hooked on science fiction. I used to read a comic called The Eagle, which had on its front page Dan Dare, the pilot of the future.
Oh, yeah, I've heard of that.
Yeah, it's classic stuff. Actually, I think I learned a lot of my science from that, because its author and artist, Frank Hampson, did everything he could to get the science right. The bit that, of course, is always done in science fiction is that the distances involved are compressed so that you can get from A to B either in the solar system or in the galaxy or indeed in the universe in a time span that doesn't last for tens of millions of years, because that's the nub of the issue. The reality of the universe is exactly as Douglas Adams said in The Hitchhiker's Guide to the Galaxy: space is big, and it is mind-bogglingly big by our standards. So I think where we are at the moment, and we clearly live in a privileged time, Andrew, compared with any other era in the history of our species, we are seeing ourselves, and in particular our robotic spacecraft, flitting around the solar system. The solar system is very much becoming our local neighborhood as far as exploration is concerned, but it is all robotic at the moment, because robots are much easier to deal with than humans. They're a lot better equipped to withstand the rigors of space. You don't need to feed them, you don't need to allow them to breathe, and you don't need to protect them to the same degree anyway from radiation. And these are the issues that face human space flight. So when Jordan asks about civilization being able to travel to other planets, I guess what he's thinking of is a mass movement of people between the planets, and I suspect eventually that will come. But I think we are at the moment at a time when it's premature even to think about that. Although there are people in the world who are thinking about it, and of course one of them has been in the headlines in the last few days. His name is Elon Musk.
Yes.
His launch of the Falcon Heavy rocket, the successful launch into space of his Tesla Roadster, putting it in an orbit that will intersect the orbit of Mars and the orbit of Earth. It's an elliptical orbit, and you'll probably keep winding around that for the next billion years or so. Look, that's all visionary stuff. And Falcon Heavy certainly represents a huge milestone in space travel, because the idea of bringing back the boosters to the surface of Earth, which he did actually 2 out of 3 of the boosters came back safely, the third one didn't. That step that has been taken is an enormous one in terms of bringing the cost down to actually allow commercial space flight to exploit, the possibilities that we can see that we can't yet grab yet because it's too expensive. It's if I remember rightly, I don't know, my figure that comes to mind is something like $4,000 a kilogram to get things into orbit. It might be more than that. It's a huge amount. But what Falcon Heavy does is to show the way to bringing that cost down. Now, Falcon Heavy for Elon, however, is just a stepping stone to his next project, which is the BFR, the Big Falcon Rocket. And the Big Falcon Rocket is what he proposes to take large numbers of people to the planet Mars in the end. And he's talking about doing that within a matter of decades. It's not something I actually think we're ready for yet. I think there are all kinds of issues with it. One is that if you start talking about this sort of thing too early, then you raise false expectations in people. The technical challenges are still enormous to get people to Mars. Even at, 2 or 3 NASA astronauts, getting them to Mars is still a huge challenge, let alone sending thousands of people to Mars. So I think it's premature. It also raises the question of what if there's indigenous life there already? We might find living microbes or evidence of past life on Mars. We don't know. And I actually think as well, the bigger challenge for us is to fix up our own planet so we're not trashing it the way we are at the moment. And I have to say, Elon is contributing to that as well, because he's, pioneered the electric vehicle in a way that glamorizes it and makes it very appealing to people. It's great stuff.
Oh, yeah. So, I mean, that Tesla Roadster's out there now and it's floating around. And is it in anything, or is it floating free?
No, I think it's actually mounted on the pod on the final stage of the rocket. Just returning then to Jordan's question, look, I think in the long term we are going to be a truly spacefaring species. We probably won't go much further than the confines of the solar system unless physics sees a new breakthrough in allowing us to cover these enormous distances.
Yeah, like folding space or something as extreme as that.
We're light years away from that at the moment. But I do think it's part of our destiny, assuming we don't get wiped out by an asteroid or a supernova or a runaway virus or each other. That's right.
Yeah.
It's possible that all those things could contribute to our demise. That's actually one of the motivations Elon has for trying to get us off the Earth, because we're a single point failure here. If something bad happens to the Earth, then that's the end of it.
Yes, indeed. So we're going to have to. Let's assume for a moment we do last long enough to survive to the point where Earth is uninhabitable. We will have to migrate. We will have to find somewhere else to live. So these things need to be looked at, and what better time than now to start considering it? You don't want to leave it till the last minute.
Exactly. That's right. The last minute is the wrong time to be escaping from a doomed Earth.
Yes, very much so.
Yeah.
All right, Fred, thank you as always. Thank you to Jordan for the question, and keep your questions coming. We love to hear from you, so definitely fire them through to us via Facebook or Twitter or whatever way you want to send them to us, and we'll do our best to answer them. Sometimes they get through to the keeper, which is a cricketing term which most of you probably don't understand, but it means we forget. But we'll do our best. And if we do miss one, remind us, send it to us again. We'd be happy to follow it up. Fred, as always, thank you so much.
Great pleasure, Andrew. Good to talk, and I look forward to the next time.
Forgive the peanut gallery from my radio station who just wandered in and started yabbering in the background, but these things happen sometimes. But until next time, thank you for listening and enjoying Space Nuts. We'll catch you again soon.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.